A similar size tsunami could happen right here on the Oregon coast. We chose to the seaside, finding the coastal towns. A miniature version of Seaside and unleash a tsunami on that scale to size.
Mount Everest, 35 feet, almost 5.5 miles.
Looking at the nighttime side, you'll see evidence of human civilization, the lights of the world. The white represents electric lighting from buildings and streets. The orange shading shows fires, and the blue spots are from oil rigs burning off gas in huge flares. Heavily populated areas are covered with white lights. You can easily trace the Nile River by the string of lights that follows it. Major highways can be traced out from the lights of the towns along the roads. The green lights you see near Japan are fishermen shining bright lights into the seas to attract squid to the surface.
I'm going to put some air in. Oh my God! Try that out.
roof bolting is the most effective technique. Once the coal has been removed from the working section of the mine, about the size of a large room, the roof bolting machine, designed and built by FMC Corporation, drills holes into the ceiling. A bolt is anchored into the stronger sandstone above the coal seam to hold the roof in place. This drilling pattern provides a safer area in which miners can work. Without this safeguard, the roof might sag and eventually collapse. FMC roof bolting provides a safer and more permanently secure environment than former methods of roof support.
The reason we want that hole there is because in a second we're going to explode the wall. Not really, but they would have done that. So in order for the debris not to go all over everyone in the mine, when we have that hole under there, when you explode the wall, the debris is just going to fall down into that hole. So it creates a space for a controlled implosion rather than an explode. Okay, I'm going to go ahead and run the undercutter. It's a little loud, so you might want to plug your ears. So now that we have this hole, the next step is to drill a hole into the face so we can stick some explosives in there. That would have been done with this. This is called a face drill because it drills into the face, right? Before this machine was invented though, we would have used a hand crank, and then someone called a runner, you can guess why in a second, would have lit a stick of dynamite. Aha, now we know what he's called runner. Stuck the dynamite in the hole, yelled fire in the hole, and ran away as fast as he could. This person was often a 7 to 14-year-old boy. The reason they used boys is because they were often smaller and faster than grown men and could get away more safely because coal seams were often only 3 or 4 feet high. Thankfully, a couple things about this practice changed when these machines were invented in the 1930s. The first is we don't use dynamite anymore because it's probably not such a great idea, right? Now we use compressed air canisters, which work exactly the same way as a shaking can of pop. All that air goes under pressure and it explodes. The second thing that changed in the 1930s is we don't use children in the mines anymore because of unionization, which happened in 1933 and child labor. Entire 8-hour workday simultaneously. So this machine is basically just a combination of everything we've seen so far. So we've got some sprayers that are tamping down the coal wall, just like we saw the sump pump. We've got a conveyor belt under there that's taking the coal away, just like the joy loader we saw, that orange machine. It has a built-in methanometer that shuts the machine off when it's 2.0 and it's time to go. And that rotating head takes the place of the undercutter, the face drill, and the dynamite. We don't need explosives anymore because that thing shears the coal off like butter. Those orange chips that you see are made of steel carbide, which is the second hardest material on Earth, second to diamonds exactly. Yeah, we use steel carbide because it's spark-proof and it won't set the wall on fire. This is also a very short cross-section. This machine is often up to 500 yards long, and this hydraulic lift goes all the way down. This is an awesome part of this machine because it lifts up the ceiling to provide against roof collapse, which means we don't have to leave pillars anymore. So we can extract 80 to 90% of the coal instead of just the 40% that we were able to extract before because we have our own personal roof lifter so it doesn't collapse on us. So this machine is so huge, how do you think they got it down here if the man cage is the only way in or out? In pieces, exactly. They would have assembled it down here. And since every coal mine is different size and has different needs, each of these machines is custom made for each mine, which means they're only usable once. And after they're used, they're taken up to the surface and sold for scrap metal, which comes with a pretty heavy price tag. These can go anywhere from $30 to $300 million, depending on how big they are. Which is why they're also not the most popular machine. There's only 4 operational in Illinois today and 48 in the United States. There's a smaller version called a continuous miner, which is basically that rotating head on a small tractor. So they're much cheaper and much more popular for smaller mines that can afford this machine. This is also a very heavy piece of machine.